Hello, I'm John Roskam, Senior Fellow at the Institute of Public Affairs. Welcome to this special edition of IPA Encounters with Steven Koonin, the author of the best-selling book, Unsettled, What Climate Science Tells Us, What It Doesn't, and Why It Matters. Steven is an eminent physicist. He was the Undersecretary of Science in the US Department of Energy under President Obama from 2009 to 2011. Born in Brooklyn in New York, Steven graduated from high school at the age of 16. He received his Bachelor of Science degree from the California Institute of Technology and his PhD from the Massachusetts Institute of Technology in theoretical physics. He then joined the faculty of the California Institute of Technology and was the Institute's Provost and Deputy Vice-Chancellor from 1995 to 2004. He then joined BP as Chief Scientist. Following his work with the Obama administration, in 2012, he was appointed the founding director of New York University's Center for Urban Sciences and Progress. He is the author of more than 200 peer-reviewed papers in physics, astrophysics, scientific computation, energy, technology, policy and climate science. He is the author of a key textbook on science, computer modelling and physics. The Wall Street Journal, in its review of Unsettled, said, "Any reader would benefit from its lucid tour of climate science. It is the best of its kind to have been written. The rigorous parsing of the evidence will have you questioning the political class's compulsion to manipulate certainty where certainty doesn't exist." What I discuss with Steven in this edition of Encounters is why he wrote Unsettled, how it was received, and then we talk about the future of energy, including the future of nuclear energy. I hope you enjoy this edition of IPA Encounters with Steven Koonin. So, Steven, can I ask you firstly, why did you write Unsettled?
I first really started to look into climate science about 7 or 8 years ago when I was asked by the American Physical Society to redo or help them redo their statement on climate science. And so I dug deeply into the literature, the scientific literature, and the assessment reports that existed at that time. And I felt already at that time that the science, as I would read it as a scientist, was somewhat less certain than the popular and political discussion. And then in the subsequent years, up through about 2017, I watched a growing chasm between what the politicians, the media, and the NGO were saying and what the science actually said. And I got so annoyed that about 4 years ago, I decided to write a book. And the goal for the book was not to try to persuade anybody of one thing or another, but simply to lay bare what was there in the reports and the literature, because nobody but the scientists read those documents. In one of the best introductions I've had in the last 7 or 8 months, I was likened to William Tyndall. And I didn't know who William Tyndall was. I had to go look it up. For those of you who might not know, he was one of the major figures in the Protestant Reformation. And in the early 1600s, he had the temerity to translate the Bible from the original Greek and Hebrew into English, and so make it accessible to everyone beyond the clergy. People got very mad, or at least the clergy got very mad at him. He was eventually burned at the stake. I hope that doesn't happen to me, but my goal is similar, and that is to make the official science accessible to everybody.
What has the reaction been to you having been an official in the Obama administration? And correct me if I'm wrong, but by and large, Steven, you are more likely to be identified as a Democrat than as a Republican, if anything.
Yeah. If I look at the center of my political feelings. It's closer to the center left or Democratic than it is to the extreme right. I can imagine center right as well. And unfortunately, for various reasons, the center has emptied out in American politics. We can talk about that later. But I like to think that we scientists, and particularly those of us who provide scientific advice to the government, really need to try to be apolitical. You know, there's a long tradition in the US of the military being apolitical, never registering for a particular political party. I have never registered myself for a political party because I think the proper role of scientists is to inform the decision makers, the background facts, the possible courses of action, and the consequences of any particular course of action, and not make the decision, not try to persuade one way or the other. Because in fact, often these decisions involve a very complicated balancing of facts together with values and political calculus and so on. And that's just not the scientist's role. Unfortunately, at least in climate science, many of the people providing the advice don't have that attitude. And I think I have it because in previous parts of my life, and still currently, I advise the US government on other very important matters. And I was trained by a previous generation in how to do that. And I think the current generation of climate scientists just don't really have that perspective.
What's been the reaction to Unsettled? What surprised you? What pleased you? What disappointed you?
Yeah. So on the pleasant surprise side, I'll just start with the numbers, right? We've sold, last I checked at the beginning of this month, 150,000 copies. Between that and the audiobook and the ebooks, for a book of this type, I had no sense of what to expect. My agent and publisher say it's spectacular. So that's been pleasing to see that there's a receptivity to the message. I get many unsolicited emails from people who aren't climate scientists, engineers, scientists in other fields, business folks who say, thanks for writing this. Because what I think I did was to provide a framework in which to think about climate issues and to some extent energy issues, and then filled it in. I was very careful in writing the book to stick so almost entirely to what was in the official reports at the time or the peer-reviewed literature. So it's very difficult for a climate scientist to say, you got it wrong. Nevertheless, there are many climate scientists in public who will say, Koonin's not a climate scientist, he's a shill for oil companies, et cetera, et cetera. But when you look at factual criticisms, it's pretty thin. I was disappointed when about a dozen climate scientists, firmly, rabidly in the consensus, wrote an article in Scientific American, more than roughly 2,000 words, and almost all of it was an ad hominem attack on me. There were 3 substantive points about the science, and they were easily rebutted. I wrote such a rebuttal and submitted it to Scientific American, asking them to publish it. They refused without comment. And that's very disappointing. The tenor of the conversation is, in public at least, is awful.
Steven, you mentioned the Scientific American, and I read that review of Unsettled. And as you said, it was not a review of the book, it was a series of ad hominem and irrelevant attacks. And there's one section that struck me, and I might, Steven, ask for your opinion on this. The review said, quote, this is from the Scientific American. They quote you, Greenland's ice sheet isn't shrinking any more rapidly today than 80 years ago. So
the review quoted your statement, and then this is the statement from the reviewer, quote, "But for a risk-based approach to climate discussions about what we should do, this statement is irrelevant. It is the future that worries us." End of quote. Now, Stephen, when reviews dismiss evidence, when reviews dismiss data, how can one respond?
Well, on that particular point, I responded. I got so mad, not only for the logical disconnect, but for conflating projections with what has been. I got mad enough, I wrote an op-ed in the Wall Street Journal that was published in February, where I had the temerity to get them to publish a graph with the actual data. And of course, the data show, first of all, the statement is correct. 1930s, Greenland was losing as much ice each year as it has in the last, let's say, at 2020. But more importantly, the graph shows a great deal of up and down, even as the globe warms, which suggests that there's something else going on besides the temperature getting warmer. And in fact, I cited, although the Wall Street Journal didn't put the references in, I cited peer-reviewed papers over the last few years that suggest it's got to do with long-term cycles in the North Atlantic. And again, if you look at the last 4 or 5 years, the rate of melting is actually going down. And if those cycles are driving it, it'll go down and down again until 1940 or so. 2040.
Just before we talk about the policy consequences of this, I might just read for the very few of us who haven't read Unsettled as yet, your description of your assessment of the science, which to many people would be completely unobjectionable. And I'll ask you at the end of it why you think it is so objectionable. So this is Stephen's description of his assessment of what the literature and the data and the science says. And I quote, this is Stephen: "The Earth has warmed during the past century, partly because of natural phenomena and partly in response to growing human influences. These human influences, most importantly the accumulation of CO2 from burning fossil fuels, exert a physically small effect on the complex climate system. Unfortunately, our limited observations and understanding are insufficient to usefully quantify either how the climate will respond to human influences or how it varies naturally. Projections of future climate and weather events rely on models demonstrably unfit for the purpose." What's objectionable about that, Stephen?
I think I just don't find anything objectionable about it. And I've been gratified that there have been experts who've been speaking out already as recently as the last couple of weeks, saying that the models are not fit for purpose. I think what people find objectionable, again, is conflating what we should do, which is a values discussion, priorities, and so on, with just the scientific facts. I can believe somebody will look at the current scientific situation and say, you know, for the benefit of precaution, the famous precautionary principle, we should cease all emissions immediately. But you have to admit, I think, that if you look at the state of the science, it doesn't really give much compelling evidence that we're facing a catastrophe.
And before we move off the science to the very powerful second part of Unsettled, which is why this has happened, can you just talk a little bit about your description of the so-called telephone line, whereby a lot of scientists know that the data is unsettled, is unsure, but then it gets translated for policymakers into 100% certainty. Could you talk a little bit about that phenomena, please?
Sure. There is, you might ask, how does scientific information feed into the public, into the media, and into the political dialogue? And as I mentioned, the basic scientific research in the peer-reviewed literature, the data, and the assessment reports themselves are pretty inaccessible to non-scientists. And even for me, I had to spend quite a bit of time going through them in great. The most recent UN assessment report that was issued in August, part 1 of AR6, is 3,949 pages. And it took 200 scientists, 2 years to write it. And, as a scientific assessment, it's not bad. It's pretty complete. You might quibble here and there with the judging CV, but it's not bad. But clearly, no non-scientist is going to read that and understand it. And so the UN and the US government, the Royal Society in the UK, do periodic assessment exercises. The UN most recently issued the most recent one a couple months ago. The US government issued its most recent one in 2018, 4 years ago. And these reports are meant to summarize, survey, assess, and distill the science for policymakers. That gets embodied in a so-called summary for policymakers, SPM, as it's called, the first draft of which is written by the governments, not by the scientists. And then the scientists get to weigh in and tweak things a little bit. That, and then even further down the chain, press releases derived from that go out to the media and the politicians. And there are ample opportunities for misbehavior as information gets transmitted, distilled, packaged down that chain. I can go into many examples. Some of them are in the book, as you might recall. But what I would say is that all of that is not a coordinated conspiracy so much as it is an alignment of interests. The media are a major player in this, and for them, unless it's dramatic, if it bleeds, it leads, they're not going to get any eyeballs. For the politicians, I like to quote H.L. Mencken, who was an American journalist working in the early 20th century, and he said, the purpose of practical politics is to keep the electorate alarmed by a series of mostly imaginary hobgoblins so that they can be clamoring to be led to safety. And if you look at politics through those eyes, you can see it in so many instances, not only with respect to climate. And then there are the scientists, right? Fame and glory, grant funding, and so on. So, and the NGOs, of course, if you have established an organization whose purpose is to reduce carbon dioxide emissions to save the planet, hearing that it's not so bad is not something that you want out in the public. So all of those things conspire together in many ways. And then I think there's a final factor in that we humans have somehow a deep psychological need to think that the end of the planet is coming unless we do something. And it goes all the way back to the Bible, of course. You can find similar stories. So all of that together makes climate a wonderful subject with which to motivate, deceive the public.
And just before we get on to discussion about energy and policy consequences of all of this, Stephen, you're a scientist, you're a physicist, you've worked in government think tanks, but you're a keen observer of the media. And you make a very important point about the media, which is something the IPA has focused on and talked about, given our commitment to freedom of speech and a free media. And you make this point in the discussion about the role of the media in this, and you say it about America, but I think it applies to Australia. I think it applies to the UK as well. And I'll ask you to talk about this. In the years since the 1980s, US media outlets have developed more explicit and more differentiated points of view themselves, and thus likewise have seeped from editorial pieces, have seeped from reporting into editorial and opinion pieces. You make the point that the media is now barracking, and of course they don't just barrack for a side on climate change, they barrack for a side in many other policy fields too. Can you talk about what you think explains this phenomena?
I think it is a combination of, again, needing to generate clicks and eyeballs, circulation in an old-fashioned hard copy paper. But I think it's also activist reporters. I'm told by old-time journalists that people went into journalism to try to educate people, tell a story, factual, just the facts. I think the younger generation go into journalism in order to foster a cause. And given the way young people are educated these days, almost always that cause is on the left. And so you see most of the media in the US drifting toward the left. I would say the most rightward of the mainstream media in the US, the Wall Street Journal. And it's very interesting to see the disconnect between the editorial page and how the news is covered in the news section. So they evidently still maintain a separation between the newsroom and the editorial pages. Most papers have stopped that entirely. There is, in the climate, one more remark, and then we'll move on. There is an organization, an international organization called Covering Climate Now. And they have a website, and what it is a consortium of media outlets, including the BBC, National Public Radio in the US, Scientific American, The Guardian, you wouldn't be surprised. I'm sure ABC is a member or could well be. And what they have done is to agree among themselves not to publish anything that disagrees with the climate narrative. And that is just so wrong. I could go on, but okay. That's my take on the media.
Let us talk for 10 minutes about energy, and then we've got questions from the group. Steven, would you like to summarise the state of the debate about energy?
Yeah. I think the current crisis, or even starting with the Glasgow Conference of Parties that happened in November, that and the subsequent developments around Ukraine, but also the recovery from the pandemic, have brought home to many people some fundamentals about the energy situation that have long been evident to anybody who's taken the time to study it. The metaphor I like to use is, I don't know, do you have Roadrunner cartoons in Australia? Is that a familiar? Yeah.
Yes.
So occasionally, that Wile E. Coyote gets run off of a cliff by Roadrunner. And you often see him suspended in midair with I would say, a shocked look on his face, because he realizes that there are some fundamentals in his situation that are going to spell a very bad outcome. And that's exactly what has happened in the last 5 months or so. The world has come to realize that reliability and affordability are much more important than low emissions or clean. And, there are things that one should understand. I teach in my course with examples. Energy systems take decades to change. There are fundamental reasons why that's true. Large capital costs, need for interoperability, reliability, and so on. The energy situation is different in every country or every region within a big country. Wind, solar, and other modern energy technologies like electric vehicles, much greater amounts of material and very different kinds of material, including rare earths, copper, cobalt, nickel, much more than conventional technologies do. And if we're going to deploy those technologies on a scale that some folks would like, and at a pace some folks would like, we're going to see a tremendous uptick in demand for those materials, and hence much greater mining activities in countries that may not be so friendly to us. China, for example, has the bulk of the processing for many of these materials. That's not a comfortable situation to want to be in. Another is that, if you take a grid that's very dominant by wind and solar, then you need backup. And you need a backup capacity that's actually more expensive than the wind and solar itself, because once every 5 or 10 years, there are a few week periods where the wind doesn't blow or the sun doesn't shine or both. And then if you want reliability, you're going to have to pay for either nuclear power or big backup batteries or carbon capture and storage with gas. So, the most expensive thing about the grid that people want to build is the reliability. It's not the generation itself. Another thing one more fundamental, or two more, and then we'll move on. One is that in the US, there's a lot of talk about energy independence. And most of it is coming from the right. And I think it's a little bit misinformed, because energy independence is one thing, and it's important to have physical supplies of oil or gas, but that's not the same as price independence. And it is the price independence that matters to most consumers. Oil and increasingly gas are globally traded commodities, and any one country doesn't get to set the price unless it's got enough capacity to produce that it can be the swing producer. So I think some of that is important to get people to understand. And then finally, I think almost anybody who's looked at it realizes that nuclear power, fission, has got to be a big part of any solution that gets to reduced emissions. And of course, there are a lot of people who don't like that either.
Could I ask you, Stephen, from an Australian perspective, as we hope we are about to have a debate about civil nuclear power in this country, and you would have seen that the Australian government, the US government and the UK government have initiated a new security arrangement which involves Australia gaining access to nuclear-powered submarines, and you may be familiar with the contradiction whereby we can have nuclear-powered submarines but not nuclear electricity. How would you explain to the Australian public and to Australian policymakers the potential need for nuclear energy?
There's a further, it's a tripartite contradiction, by the way. If I remember right, Australia is a pretty big miner and exporter of uranium. And where do people think that uranium goes, right? So, it's a lot like Norway. Norway is holier than thou with respect to emissions reduction, but they produce 3 million barrels a day of oil and are rich because of it, right? So consistency is not so important in these discussions to many people. We need what's called firm power that you can count upon independent of the weather circumstances. Right now, the only way to deliver emissions-free power is through nuclear energy. Carbon capture and storage fed by gas or coal is another, but it's way too expensive and not really a proven technology. And enormous batteries, pumped hydro. Well, the pumped hydro is pretty good, but it doesn't scale and will depend upon droughts and so on. And the batteries just aren't there yet. You can't do it. So if you want a grid that is largely renewables, you must have this backup. And nuclear power is the only scalable and technically proven way to do that. It generates already 19% of electricity in the US, 70-something% in France, 30% in Japan, and so on. The deaths per kilowatt hour produced are essentially the lowest of any energy technology, much lower than gas, even lower than wind if you count bird deaths as well. So, when you look at it quantitatively, not emotionally, it's a no-brainer.
Just before we go to questions from the group, can I ask you, Stephen, to explain net zero by 2050 to us?
So the narrative, and I'm just quoting now the official line, we can go into what I believe and what I don't, but the narrative is that we should not let the global temperature rise go above 1.5 degrees above the pre-industrial temperature, lest we risk dangerous human influences on the climate system. Just a diversion for 30 seconds on 1.5 degrees. It's a very fuzzy number. As I recount in the book, I asked the guy who's the father of the 2-degree limit, why did you pick 2 degrees? And he said, it's an easy number for politicians to remember. And now, the politicians have fastened on 1.5. I guess their memories have improved a little bit. It could just as well be 2, it could be 2.5. There are arguments why it could be even as much as 3. And in order to achieve any one of those limits, but particularly 1.5, we would have to stop all emissions. So no burning of fossil fuels, except if it's sequestered. Agriculture has to go emissions free. And that has to happen by 2050. Given that emissions have been climbing at 1.5% a year, even now, and a bit more in recent years because of the recovery from the pandemic, it's absurd to think that we're going to get to zero by 2050. Some people say net zero, which means that we should also be pursuing actions that will suck carbon dioxide out of the atmosphere, as well as reducing the amount that we're putting into it. So I think net zero by 2050 is a fantasy. By 2100 would be a real stretch. But the good news is that the projections of at least economic impact of a rise of as much as 4 or 5 degrees are a few percent of the economy in 2100, which is a few years of growth. And so it's not going to be anywhere near as bad as people think it is. And it might even be beneficial in a number of parts of the world.
You talk a lot about the dangers of modeling, the dangers of projecting things, but I'm going to ask you to do exactly that. Model and project the next 5 or 10 years of discussion about energy in the West. What do you see potentially happening, and what do you see us responding as?
I think there'll be a growing realism among the general public about what's important and what policies and technologies we're going to need to satisfy reliability and affordability. I think in the US, I don't know the Australian political scene very well, but in the US, we have a midterm election coming up in November. And I think a major factor is going to be rising energy prices. And I think that's also true for the presidential election in 2024. We need to expand in the US domestic oil and gas production, absolutely. And both for the US, but also increasingly for the world. I hope Australia will look for a robust energy system and stop the trends that you mentioned before. So I think on the time scale of 5 to 10 years, that's what's going to happen. One more riff a little bit. I've been reading the social scientist Anthony Downs, who was writing in the early 70s and talked about the issue attention cycle. He invented it, where phase 1, a problem bubbles among the experts below public consciousness. Phase 2, it bursts into public consciousness, and there's great enthusiasm for finding a solution. Phase 3 is when the public starts to realize just how difficult it's going to be to solve the problem. Phase 4, you see diminishing attention, and phase 5, it's just part of the background. And the real issue is whether climate, human influences on the climate are going to, I think we're in about phase 3 right now. Is it going to fade quickly, or will it take quite a while to fade, or will we actually solve it? And of course, I've already said, I don't think we're going to get to net zero anytime in this century.
Steven, a final question. Are you optimistic for the future? And if you are, why?
Oh, I'm absolutely optimistic. Okay, absolutely. Human ingenuity is spectacular. I mean, it's probably the defining characteristic of our species. To take a recent example, COVID emerged, surprised almost everybody except a few experts. And the world has figured out how to deal with that. I think the vaccinations play a role, maybe not in preventing spread, but certainly in lessening the impact for people who do catch the disease. We have therapeutics. We understand so much. And that's been built on 40 years of investment in biology, chemistry, and medicine. And it's hardly the existential crisis some people thought it was a couple of years ago. And so we as humans, we roll with the punches and sometimes exploit them rather than just act to mitigate them. So of course, I'm optimistic. It'll be a different world, but our children and grandchildren will certainly thrive.
Stephen, that is a wonderful note upon which to conclude this discussion. Can I thank you for your generosity? It's been wonderful working with you. And most importantly, can I thank you for what you're doing for science and for the public debate, not just in the United States, but you've had a huge impact on the debate here in Australia.
Thank you.